This right here is an equation for a parabola. And the goal of this video is to find an alternate or to explore an alternate method for finding the focus and directrix of this parabola from the equation. So the first thing I like to do is solve explicitly for y. I don't know, my brain just processes things better that way. So let's get this 23 over 4 to the right-hand side. So let's add 23 over 4 to both sides. And then we'll get y is equal to negative 1/3 times x minus 1 squared plus 23 over 4. Now let's remind ourselves what we've learned about foci and directrixes, I think is how to say it. So the focus, if the focus of a parabola is at the point A, comma B, and the directrix is the line y equals k. We've shown in other videos with a little bit of hairy algebra that the equation of the parabola in a form like this is going to be y is equal to 1 over 2 times b minus k. And this b minus k is then the difference between this y coordinate and this y value, I guess you could say, times x minus 1 squared plus b plus k. Oh, sorry, not x minus 1. I'm getting confused with this. X minus a squared. X minus a squared plus b plus k over 2. If the focus is a comma b, then the direction is y equals k, then this is going to be the equation of the parabola. Well, we've already seen a technique where, look, we can see the different parts. We can see that, okay, this x minus 1 squared, actually, let me do this in a different color. This x minus 1 squared corresponds to the x minus a squared. And so 1 corresponds to a. So just like that, we know that a is going to be equal to 1. And actually, let me just write that down. A is equal to 1 in this example right over here. And then you could see that the negative 1/3 over here corresponds to the 1 over 2 b minus k. And you would see that the 23 over 4 corresponds to the b plus k over 2. Now, the first technique that we explored, we said, okay, let's set negative 1/3 to this thing right over here. Solve for b minus k. We're not solving for b or k. We're solving for the expression b minus k. So you get b minus k equals something. And then you could use 23 over 4 and this to solve for b plus k. So you get b plus k equals something. And then you have two equations, two unknowns. You can solve for b and k. What I want to do in this video is explore a different method that really uses our knowledge of the vertex of a parabola to be able to figure out where the focus and the directrix is going to be. So let's think about the vertex of this parabola right over here. Remember, the vertex, if the parabola is upward opening like this, the vertex is this minimum point. If it is downward opening, it's going to be this maximum point. And so when you look over here, you see that you have a negative 1/3 in front of the x minus 1 squared. So this quantity over here is either going to be 0 or negative. So it's not going to add to 23 over 4. It's either going to add nothing or take away from it. So this thing's going to hit a maximum point when this thing is 0. When this thing is 0, and it's just going to go down from there. And when this thing is 0, y is going to be equal to 23 over 4. So our vertex is going to be that maximum point. Our vertex is going to be, well, when does this equal 0? Well, when x equals 1. When x equals 1, you get 1 minus 1 squared. So it's 0 squared times negative 1/3. This is 0. So when x is equal to 1, we're at our maximum y value of 23 over 4, which is 5 3/4. Actually, let me write that as a, actually, I'll leave it just like that. That's our vertex, 23 over 4, and it is a downward opening. It is a downward opening parabola. So actually, let me start to draw this. So let me get some axes here. So we have to go all the way up to 5 3/4. So let's make this that's our y. This is our y-axis. This is the x-axis. That's the x-axis. Let's see. We're going to see. We go to 1. Let's call that 1. Let's call that 2. And then I want to get, let's see, if I can go to 5 3/4, let's go up to, let's see, 1, 2, 3, 4, 5, 6, 7. We can label them 1, 2, 3, 4, 5, 6, and 7. And so our vertex is right over here, 1, 23 over 4. So it's 5 3/4. So it's going to be right around there. And as we said, since we have a negative value in front of this x minus 1 squared term, I guess we could call it, this is going to be a downward opening parabola. This is going to be a maximum point. So our actual parabola is going to look something like this. It's going to look something like this. And we could obviously I'm hand drawing it, so it's not going to be exactly perfect, but hopefully you get the general idea of what the parabola is going to look like. And actually let me just do part of it, because I actually don't know that much information about the parabola just yet. I'm just going to draw it like that. So we don't know just yet where the directrix and focus is, but we do know a few things. The focus is going to sit on the same, I guess you could say, the same x value as the vertex. So if we draw, this is x equals 1. If x equals 1, we know from our experience with foci, I guess, and that they're going to sit on the same axis as the vertex. So the focus might be right over here, and then the directrix is going to be an equidistant on the other side. Equidistant on the other side. So the directrix might be something like this. Might be right over here. And once again, I haven't figured it out yet, but what we know is that because this point, the vertex, sits on the parabola, by definition, it has to be equidistant from the focus and the directrix. So this distance has to be the same as this distance right over here. And what's another way of thinking about this entire distance? Remember, this coordinate right over here is a comma b, and this is the line y is equal to k. This is y equals k. So what's this distance in yellow? What's this difference in y going to be? Well, you could call that, in this case, the directrix is above the focus. So you could say that this would be k minus b. Or you could say it's the absolute value of b minus k. This would actually always work. It'll always give you kind of the positive distance. So if we knew what the absolute value of b minus k is, if we knew this distance, then we just split it in half. The directrix is going to be that distance, half the distance above, and then the focus is going to be half the distance below. So let's see if we can figure this out. And we can figure this out because we see in this, I guess you could say this equation, you can see where b minus k is involved. 1 over 2 times b minus k needs to be equal to negative 1/3. So let's solve for b minus k. So we get 1 over 2 times b minus k is going to be equal to negative 1/3. Once again, this corresponds to that. It's going to be equal to negative 1/3. We could take the reciprocal of both sides, and we get 2 times b minus k is equal to 3. Is equal to 3. Now we can divide both sides. We can divide both sides by 2, and so we're going to get b minus k is equal to what is that? 3/2. 3/2. B minus k is equal to, oh, let me make sure it has to be a negative 3. So this has to be negative 3/2. And so if you took the absolute value of b minus k, you're going to get positive 3/2. Or if you took k minus b, you're going to get positive 3/2. So just like that, using this part, just actually matching the negative 1/3 to this part of this equation, we're able to solve for the absolute value of b minus k, which is going to be the distance between, in the y-axis, in the y direction, between the focus and the directrix. So this distance right over here is 3/2. So what is half that distance? And the reason why I care about half that distance is because then I can calculate where the focus is, because it's going to be half that distance below the vertex. And I can say, well, and whatever that distance is, it's going to be that distance also above the directrix. So half that distance, so 1/2 times 3/2 is equal to 3/4. So just like that, we're able to figure out the directrix is going to be 3/4 above this. So I could say the directrix, so let me see, I'm running out of space. The directrix is going to be y is equal to the y coordinate of the focus, so the y coordinate of the vertex. Be careful with my language. It's going to be equal to the y coordinate of the vertex plus 3/4, plus 3/4. So plus 3/4, which is equal to 26/4, which is equal to, what is that? That's equal to 6.5. So this right over here, actually I got pretty close when I drew it, is actually going to be the directrix. Y is equal to 6.5. And the focus, well, we know the x-coordinate of the focus. A is going to be equal to 1. And B is going to be 3/4 less than the y-coordinate of the directrix. So 23/4 minus 3/4, it's going to be 23/4. 23/4 minus 3/4, which is 20/4, which is just equal to 5. And we are done. That's the focus, 1, 5. Directrix is y is equal to 6.5.